Welcome to the tutorial on how to determine the anaerobic threshold using gas exchange parameter data, as well as the respiratory compensation point, or RCP, using gas exchange data. Here we have our Excel calculation spreadsheet with all of our values from our participants' graded exercise treadmill test inputted in. In order to make sure you have the correct data, you want to look at your data set for the particular subject, and we want to start with minute 3. So find about where minute 3 is, and everything below that line we want to copy and paste over into our spreadsheet. Now it's important to pay attention to the headings. So for example, our first column in our Excel sheet for our calculations is VO2 in liters per minute, and that nicely corresponds to our first column in our spreadsheet. Double check the next few columns to ensure that everything is in order. That way you can copy over multiple columns at once. You'll notice that after VE over VCO2, there's a gap. So you want to make sure that you can, again, copy over all these values, skip the relative expression of VO2 max, and then jump over to RER. All right. So once you have those values into your spreadsheet, again, confirm that you've completed the test. Then you want to ensure that your graph lines up. So go ahead and click on any data point within that first graph, and you'll see your data points highlight like this. Once they're highlighted, if you go to right-click down to select data, you should see the description of your graph here. Series represents one set of data that's being displayed on the graph. So for this first graph, our X variables are coming from our VO2 column, and our Y variables are coming from our VCO2 column, or volume of oxygen and volume of carbon dioxide. When you click on this small window depicting your Excel sheet, this will tell you where the graph is pulling its data from. If you click on the square, you'll want to make sure that the data is being pulled from this first column. So go ahead and highlight the column 1, VO2 data, all the way down, and click enter. Follow the same steps for your second column, all the way down, and hit enter. Go ahead and click OK. Now you're going to see these two highlighted boxes that are showing where the data from that graph is being generated from. You'll notice that the boxes at the top and the bottom have these selection squares, and you can see how my cursor changes when I float over the selection square. This will allow you to adjust which data points you've included within your graph. For example, let's keep an eye on our graph here and see what happens when I lower the starting values. What you'll see on the graph is our data points, which were starting at about 1.5 on our x-axis, are now going to jump closer to 2. So now you see our graph only represents data from about minute 6 on. That was just as an example. Let's bring our data back up to the top. Great. Now we have everything included, and we can move on. What you'll want to do is check all of your graphs and ensure that each data series is pulling from the correct data location. Let's do one more together before you check the rest of your data on your own. If you click on this series, you'll see that red represents VE over VCO2, and the X values are VO2. So once again, right-click, select data. Again, we're looking at the VE over VCO2 series because we're looking at the red one. So make sure you're on the correct variable here. go ahead and select your X values. In this case, it's VO2. So again, come to your VO2 column, scroll all the way down, and click Enter. Follow the same steps for VE over VCO2, which is located under column I. I think we might have missed. Yep, let's just do that again. Okay, now we know we have all the data. Go ahead and click the next series, which is our blue series on that graph, and follow the same steps for VE over VO2. And click OK. Again, now you're going to see those same squares with selection boxes showing where all the data is being gathered from. If you click off that graph and select the blue series, now you'll see that alternative column of data. Perfect, looks great. Go ahead and follow the same steps for your RCP graph, VCO2 as your X, VE as your Y, and the anaerobic threshold secondary criteria, VO2 on your X, PET CO2 on one Y-axis, and PET O2 on the other. Okay, great. Now you have all of your data selected from your graphs. Everything should line up. Now we can start looking for our anaerobic threshold using our gas exchange threshold parameters of VO2 and VCO2. If you look down in your spreadsheet below your graphs, you'll see the identification criteria for each threshold, GET and RCP. We're going to focus on the GET right now. So let's go ahead and highlight this. What we're looking for is an increase in minute ventilation over oxygen consumption and an increase in the estimate of arterial oxygen. We'll also look to see that there's no change in the VE over VCO2 relationship and no change in PET CO2. We also are looking for the nonlinear breakpoint in the VO2 versus VCO2 relationship. So according to the Beaver V-slope method, which Beaver in 1986, we can determine where the anaerobic threshold is by looking for that nonlinear increase in VCO2 relative to VO2, meaning that for every unit of oxygen consumption, we see a greater relative rise in VCO2 for each of those changes in VO2. So if we look at our data, we can see that there's a nice, pretty good linear relationship here. It goes up nice and steady. Kind of in this region here, we see that there might not be a straight line anymore, and it kind of shifts in the upward direction. So if you can kind of imagine, now we have more of a curve relationship, or the relationship kind of heading up in a more straight configuration at this point. You'll notice that your graph spreadsheet also has this graph, which is an identical version of this first criterion graph here. This is going to show you the data in a little bit more spread out manner, and you can stretch this graph however you need to kind of see the spread of data a little bit better, like I've done. But let's take a look here again. So we have a nice group of data here, nice and straight, and kind of in this region here, we see a little bit of a breakpoint and a slight divergence from linearity. So let's take a look at the data here. So it's about 2.9, 3.0, 3.11 for VO2, 3.11, 3.19. So we're kind of looking in the threes, right? That's where we're going to start our investigation. So come back down here, double check your criteria, and let's set up our data. So we're looking for an increase in VE over VO2 and an increase in PET-O2. We think this might occur maybe starting when we start to see those threes. So somewhere in here in this region. So we're kind of going to look at all of our data below our 9th minute. And now we're looking for an increase in these two columns. So our VE over VO2 and our PET-O2. So let's take a look. It's important to look for a pattern of increase because you'll see that each 20-second average is going to be slightly different. So starting with PET-O2, we have 119, 120, 119, 122, 121, 120, and then we see a jump to 125, 123, 122, 123, 124. So kind of at this point, right around here, we see all of our values are going to be above 120. So there's a pretty obvious jump there. Let's check VE over VO2. It's starting back at our initiation location. 25, 25, 26, 25, 27, 26, 25. Then we're jumping to 30, 29, 28, 29, 30, 30, 32. So again, right around here, which corresponds to this increase we saw in PET-O2, we're seeing those two variables increase. So let's mark. Oops. Let's mark this spot. Now we want to check our secondary criteria. We're looking for no change in VE over VCO2, no change in PET-CO2. This would mark our secondary criteria. So around this area, we're looking for no change. So let's see 33, 35, 35, 31, 33, 33, 33, 32. 25, 29, 28, 27, 28, 29, 29. So probably maybe closer to this data point, right around here, we can see that those variables are, relatively speaking, staying within about 1 of each other. So that can, in part, confirm that secondary criteria. So we could probably be fairly confident that our GET is one of these two values. Looking at our time, right around 10 minutes, 20 seconds. So now we can double check our graph to see if that makes sense. So again, we're picking these are our VO2s. Now let's go to our graph. And let's set this graph up so we can look at the relationship before and after our proposed GET. Go ahead and select your data and right-click. Select data, add a series. That will be series 2. If you want, you can even name that series. So let's say our series 1 name is before GET, and our series 2 is after GET. Go ahead and select your data. So let's go and include everything, including that 3.09 value. Our Y variables are VCO2, so let's go ahead and again include everything up until that value. Go ahead and click on your second series. And now we want to include everything after. So let's do 3.2 and below. Same thing for our Y. Go ahead and click OK. Now we have this same graph of data now displayed in 2 different series, blue and orange, or before, up to GET, and then after GET. Let's lay over a regression line so we can see if it does in fact have a nonlinear rise in VCO2. Select your data again and go to Add Trend Line. It'll automatically add a linear line, which is what we want. If you go to Forecast, you can stretch that line past your data or past the data points available. I'm going to choose 1 because if we look at our units, it's in liters of O2. So either 0.5 or 1 would be an appropriate unit of measure for these forecast options. Go ahead and click Enter and X out. Select your second series and repeat those steps. Right-click, Add Trend Line, change your forecast options, and X out. Ideally, right around this intersection point is where we're going to see our GET. What's important to note is that you might get some data points. So for example, 3.11 and a VCO2 of 2.98. That's actually here. So this data point, if you look at the data around it, may be a slight outlier, or it might not make sense with the pattern that appeared before. That's okay. That will, however, change the slope of your regression line a little bit. So keep that in mind. This intersection point may not be perfect. We just want to see if around that region is where we're seeing that deflection point. And it is pretty clear that after about a VO2 of 3, we will see that nonlinear rise in VCO2. This can also be done using pencil and ruler. It's just up to you which you'd prefer. This graph below is our secondary criteria. So this is where we're kind of looking for these things: an increase in PET-O2 and no change in PET-CO2. So PET-O2 is here. We're looking for an increase and then no change in PET-CO2. This one's often harder to see because it's kind of more of a jumble. Let's just move some of these graphs over here. You can see though, kind of around this area, we're seeing an increase in PET-O2, and we see this like jumble in PET-CO2, which could mean that those values are staying relatively constant. Where does that occur? Let's kind of track down with our cursor all the way down to our x-axis. And again, it's kind of right around 3 again. So this cluster is showing a mixture or fairly similar values in PET-CO2 is occurring right when that blue line PET-O2 starts to increase. And that corresponds to these 2 criteria. So we're looking pretty good. The last thing you can check is the RER. So let's just check our data points here. Our RER should be at least 0.97, and it is. It's either 0.98 or 1. Either of these values would work in terms of an estimate of GET. The 3.09 might be a little bit safer because it does seem to increase fairly consistently after that point. So for my selection, I would say that 3.09 is the VO2 corresponding to the GET for this individual. Great, we're done with the anaerobic threshold. Now the next step is to find the respiratory compensation point. RCP criteria, let's kind of unhighlight this for a second, are right here. So we're going to be looking for a few different variables, but using all of the same techniques that we did for the anaerobic threshold. So let's go ahead and take away these highlights just to make it a little bit easier for us. And we'll just keep this one highlighted. Okay. So we're looking for an increase in VE over VCO2 and an increase and VCO2 and VE. So let's mark all the ones that should increase. Go ahead and highlight those. Now the RCP is, again, the demarcation point of the heavy and severe domain. So it is going to occur later within the exercise task. So you can be sure that it's happening after your GET. So it is going to occur after the 10-minute and 20-second mark. So paying attention to these columns, we're looking for a pretty steep or dramatic increase in these variables. You can look down pretty consistently in the 3s, 3.6, 3.6, 3.5, and then we jump into the 4s. For VCO2 or for VE, we have 99, 103, 107, 109, 111, 116, pretty big jump, and then another big jump to 126. So right here, we're seeing a pretty dramatic rise from minute 13 minutes 40 seconds to minute 14. Let's check our third criteria. Fairly consistent in the 2930s. Then we're jumping 30.12 to 30.6 to 30.9 up to 32. So kind of right around here is where we're seeing that big jump. So let's highlight these variables of interest. So we might have found our RCP. Let's look at our secondary criteria. A decrease in PET CO2. Where is our PET CO2? So we're looking for a decrease here. So let's look within this region, again around the 13-minute mark. We're looking for a decrease. It's fairly consistent, 30, 30, 30, 30, 30.3, 30.02, 28, 30, 29, 29. So about here, again, we see that it's going up until this point, and then it starts going back down again. So right about here is when you see, again, 30.5, 30.54, 30.52, 30.86, and then back down again. So right about here is where we're seeing that reduction. If you check your other criteria, that is the same point where you see that dramatic rise. So I'm going to mark this value here, this VO2 value, as our potential VO2 corresponding to RCP. We don't know for sure. It's important to check our nonlinear relationship. So you're going to use this graph here and create your two series to double check again. Right click, select data. Add another series. You can rename if you like. So before RCP and after RCP. Select your data. This time we have VCO2 and VE. Oops. You actually want to include, everything. Do everything up until that 4.14 value. Same thing with our Y. Everything up until 126. And then our after RCP, we're just going to select these few variables. Go ahead and click OK. Perfect. Now we see two different series of data that we can now add our trend line. Same steps as before. Right click, add trend line, change your forecast options forward and backward about 1 liter per minute in terms of units. Add your second trend line. There we go. All right. So we see our intersection point of these two lines is kind of around here. But again, we have some data points that are a little bit off center. Like for example, which is this one? Let's just make this a little bit bigger. There we go. 3.85. So if you do a slight adjustment by selecting your data, so let's try including that value. There we go. We see a little bit better representation now with our crossover point. So we selected this as our RCP. We included this value in our series 2 or orange upper series. And we can see that there is that jump right around in this region here between the 3.5, 3.6 values and our RCP. And this corresponds again with our criteria of increasing values here and VE over VCO2 and no kind of steady change here in our PET CO2. So I would say at least for an estimate, this is a pretty decent estimate here of our RCP. You can check some secondary criteria, but again, we're pretty confident based on these numbers that these are our 2 thresholds. Now that you have the VO2 associated with these thresholds, you can determine the relative VO2 corresponding to the GET. It's in mLs per kg per minute. Looking back at the GXT data, you can find the percent of VO2 max at RCP or at GET and RCP for this individual. Now you should be ready to do another one on your own. It's important to set up your data sheet with the correct data, double check your graphs to make sure that they're pulling in the data from the correct spreadsheet, and then go through methodically each qualification criteria for each threshold to ensure that you're selecting the appropriate estimate of either GET or RCP.